This is part of your daily work, and what we're going to do is find domain when you compose F with G or G with F. So we're composing F with G, and the first thing we're going to notice is on this one. This is the example 3 in your book on page 251 if you kind of want to follow along. There's a little trick to these, especially if you have rational functions like we do, rational being the fraction, numerator, denominator. The first thing we notice is that the domain of g of x, and the reason we want to look mainly at g of x is because it's the one that we're going to compose with f. We notice that x is all reals, but x cannot be 1, because that would make the denominator 0. Now, we also notice that for f, the domain is x such that x cannot be -2. So that means, in this case, that g of x can't be -2. So g of x cannot be -2. So we're going to take this one and we're going to figure out where g of x cannot be -2. Okay, so basically we're going to set g of x to -2 and solve, and we get 4 equals -2 times x minus 1, and that equals 4 equals -2x plus 2, and we get 2x equals -2, so x cannot be -1. So we also going to exclude -1. So we recall that g of x can't be 1. X cannot be 1. So what we're going to take is, for our domain of f of g is x, because we're mainly looking at the g and what g cannot equal. So it can't be -1 from the previous page, and it also can't be -1. So there it is from there. That's what goes there. We don't put the -2 here. We just use that to find out what this cannot equal -2. Okay? Okay, so the next ones we're going to do are some from the textbook, and we're going to look at 21. In 21 we have let's see. Let me try to find it. Alright. 21 is, let me find it. Let's look at 21. Okay. We have f of x equals 3 over x minus 1, and g of x equals 2 over x. So what we notice is g of x is all reals but at 0, and f of x is all reals but 1. Okay, so basically we know we're going to take this for a composite function. So we already know, I'm going to put down here, f of g of x, the domain is x, but x cannot be 0. Now we're going to have to set g of x to 1. So we get 2 over x equals 1. So x equals 2. And we know that g of x cannot equal 1. So that means x cannot be 2. So x cannot be 0 and x cannot be 2. Pretty simple, just have to do this little trick in here. Okay, 23 is f of x equals x over x minus 1, and g of x equals -4 over x. So here we know that x can't be 0, and here x cannot be 1. So we're going to set this part here to 1. So our f of g, the domain, is x cannot be 0. And then we're going to find out what x cannot be here. And we're going to know, you can tell right away. So we get x equals negative 4. So x cannot be negative 4 as well. Okay? Pretty simple. 25 is f of x equals the square root of x, and g of x equals 2x plus 3. Now g can be all real numbers. So this one is what, 25? G can be all real numbers because it's no fractions. Okay, so we're going to write this x is all real numbers, and f of x, we knew from last semester, or the first part of the semester, is x, but x has to be bigger than or equal to 0. That means this has to be bigger than or equal to 0 for it to see what it excludes from the domain. So what we're going to do, it means it can't be that. So what we're going to do is solve 2x plus 3 is greater than or equal to 0. So 2x is greater than or equal to negative 3. So x is bigger than or equal to negative 3 over 2. So that means that our domain for f of g is x, but x must be bigger than or equal to negative 3 over 2. And this was 25. Okay? And the last one we're going to do is 27. 27 is x squared plus 1. F of x is x squared plus 1. And g of x equals the square root of x minus 1. And this was 27. So for 27, for the domain of this, we have x, but x has to be bigger than or equal to 1. Remember, this side here has to be bigger than or equal to 0, so that's why we get that. But for f, we have that is any real number. This one right here, we can put anything in for x. X can be any real number. So this one's kind of easy. Since we didn't have to check this, we're just going to do f of x. F composed with f of x. The domain is just that. So x such that x is bigger than or equal to 1. And that is all of that section.